Welcome back, dear students. Let us now quickly take some more examples in which we will check the correctness of a given equation using dimensional analysis. Let us as first example take this equation t equal to 2 pi into square root of L upon g, where t is the time period of the pendulum, L is the length of pendulum, and g is the acceleration due to gravity. Let us see whether this equation for the time period is correct dimensionally or not. So for that, what we do, we'll write the dimensions of the left side first, that are t. M and L are absent on this side. Then go to the right hand side and check the dimensions of this term. You know 2 pi is a number, so it has no dimensions. So dimensions of left side are square root of dimension of L, length, that is L, divided by dimensions of G, that is acceleration, which is Lt minus 2. This becomes, L and L will cancel and this will become T square. When brought to the numerator, its power will become positive. T square square root it, which is T. So you can see that the dimensions of right hand side are same as the dimensions of left hand side in this equation. Therefore, this equation is dimensionally correct. Let us take one more example. Suppose I have a small particle moving at speed v. Then in theory of relativity, we see that the mass of the moving particle is not the same as it is when it is in the rest. So the equation relating the mass at rest MO and the mass when it is moving at speed v is given by m equal to MO into square root of 1 minus v square upon c, where c is the speed of light in vacuum and v is the speed of that particle. Let us see whether this equation is dimensionally correct or not. So we will see that the dimensions on the left side are m and the dimension in the numerator on the right side are also m. These two terms can have same dimensions only if its denominator has no dimensions. One has no dimensions, no doubt, but v square upon c is not dimensionless. You know v square is the square of speed, so its dimensions will be L square t to the power minus 2. And c has dimensions Lt minus 1. These do not cancel, therefore this term is not dimensionless. It means there is somewhat wrong with this term, and the equation as such is not dimensionally correct because the dimensions on the two sides are not the same. So what can we do? We can either write it as v upon c so that the dimensions cancel, or we can write it as v square upon c square. In that case also the dimensions will cancel. But the actual equation when you will study later on is v square upon c square at this point. This way, the dimensional analysis is helpful in checking whether an equation is correct or not. Thank you. For the next application, watch my next video.